Fusion Mobile, quality e-learning experience on the go.
Good day, you are welcome to Fusion Mobile e-learning class. My name is Bolaji. I'm here to speak on the subject mathematics. And the topic before us today is statistics. Now, histogram, Ogilvy curve, which is also called cumulative frequency curve, and median, quartile, and percentile. These are what we are going to be solving in this topic, that is the group data of statistics. Now let us move on to what is histogram. Histogram is defined as a graphical representation of frequency distribution. It is defined as a graphical representation of frequency distribution. They are rectangular bars placed side by side. They are rectangular bars placed side by side, while the vertical axis represent the frequency and the horizontal axis represent the variables. I want to show you histogram, how histogram look like from our explanation. We have the frequency according to our definition, and we have the variables here. Now, this is the meaning of histogram. We said histogram, they are rectangular bar placed side by side. This is rectangular bar placed side by side. And we have the vertical axis, which is called the frequency, and the horizontal axis, which is called the variables. Now, how do we solve question under histogram? How does histogram give us knowledge about statistics? And that is what we are going to solve in this example. Let us solve this example. Now, the table below, I want us to consider this table below. The table below shows the weight of distribution of 40 students in a school. Now, we want to show how their weight is. Weight, which is calculated in kg, and the number of students. Number of students. Now, the weight of these students are 41 to 45, 46 to 50, 51 to 55, 56 to 60, 61 to 65, and 66 to 70. (45 to 45), we have 3. Then 46 to 57. Then 51 to 55, 12. 56 to 60, 10. 61 to 65, 6. While 66 to 70 is 2. Now, this is the table that shows numbers of students with different weights. We weigh the students and we now categorize them in different weights. 3 students fall between 41 to 45, 7 students fall between 46 to 50, 12 students fall between 51 to 55, 10 students fall between 56 to 60, then 6 students fall between 61 to 65, and 2 students fall between 66 to 70. Now, how do we solve this question? I would like us to look at this solution. The first thing we need to do is for us to write the table. We write the table. It's for us to write the table. And this is how the table look like. weight the weight of the student are different, and the number of students, you write the number of students, and we have what is called class boundary. Now, weight, number of students, and class boundary. 41 to 45, we have how many students? 3 students. 46 to 50, we have 7 students. Then, 51 to 55, we have 12 students. 56 to 60, we have 10 students. Then 61 to 65, we have 6 students. Then 66 to 70, we have 2 students. Then how do we calculate our class boundary? I want you to listen very well to this class boundary. There's what we call upper class boundary and lower class boundary. Now, in this is the lower class boundary. 41, 46, 51, 56, 61, 66, they are called lower class boundary. We deduct 0.5 from all through the lower class boundary, and we add that 0.5 to all through the upper class boundary. Our upper class boundary is 45, 50, 55, 60, 65, 70. Therefore, let's continue. 40.5 to 45.5, then 45.5 to 50.5, then here is 50.5 to 55.5, here we have 55.5 to 60.5, here we have 60.5 to 65.5, and 65.5 to 70.5. Now, that is how we do it. How do we get all these things? We deduct 0.5 from lower class boundary, and we now add it to the upper class boundary. That is how we get this class boundary. Now, we are not yet through because we've gotten this table. The next thing is for us to plot our graph. I'd like you to bring out your graph so that we can make use of these data effectively. Remember, we define histogram as a graphical representation. A graphical representation of distributions of data. Now, we now said at the vertical axis is represented by frequency, and at the horizontal axis is represented by the variables. Now, where is our variables and where is our frequency? I'd like you to see that we begin from 40.5. We use upper class boundary for our variables, but we have to start from below, that is this 40.5. We first start from 40.5, then we continue to use the upper class boundary. Let us start. Open to your graph sheet so that we can plot our graph. Now, this is our graph sheet. We said the vertical axis is represented with frequency, and this frequency is the number of students. Then, as the variable, we represent it with the upper class boundary. But we start from the 40.5 here. Start from 40.5. The next one is 45.5, which is the upper class boundary. But before then, we have to choose our scale. Which scale are we going to use for this? What is the highest number here? The highest number in our frequency here, in the number of students, is 12. So we can say 2 centimeters to represent 2 units on y-axis, and 2 centimeters to represent 5 units in x-axis, because 45.5 minus 40.5 will give us 5. So each of the rectangular bar represents 5 units. Now, we set 2 centimeters to represent 2 units on the y-axis. Use 2 centimeters to represent 2 units on our y-axis, where we represent with our number of students. So we start from, look at my hand, we have 2, we have 4, we have 6, we have 8, we have 10, then we have 12. So we've gotten that. Now, we have 3 here. 3, we have 40.5, but it is 45.5. So you start from 40.5 here. 3. So for that it is 3 here, it lies between 2 and 4. So it lies here, which is 45.5. Then 50.5 goes to where? 7. 7 lies here. So we draw the histogram like this bar to here, which is a 50.5. Then 55.5 is 12. So we move up to 12 from 55.5. Then 60.5 is 10. We move on to 10. That's 60.5. Then the next one is 6, which is 65.5. 6. We trace it out, 65.5. Then the last one, which is 70.5, which lies in 2. So it is 70.5. So these are called variables which are measured in kg, and this one is frequency, which is the number of students. I'd like you to check your graph very well. This is the result of the graph of the histogram. Now, we have importance of histogram. When we plot our histogram, there are some kind of value we can find within the histogram. And within this histogram, we still have formulas for it. And what are these formulas? You can use this histogram to find our mode. How do we find our mode with histogram? Look at the highest frequency. What is the highest frequency? We check the number of students here. We discover that 12 is the highest frequency. We can trace it to our graph that we plot. Check your graph. You discover that we have 12 as the highest frequency. Then what is there is that you use a sharp pencil. Use a sharp pencil with your ruler and trace what I want to show you. The highest frequency, that is the highest rectangular bar, and trace it like this. And join this one too. Where it intersects, you trace it down. Is our mode. Where it intersects is our mode. That intersection gives us a clue of our mode. Check your graph. What is that intersection? If you check it, you discover that this is 50.5. You continue to count it, 50.5. At the long run, you will discover that the intersect is where the mode lies. So the mode lies around 54.1. Go 54.1, 54.2, 54.3 up to 55.1. So here is 54.1 kg. Now, check your graph. You discover that that point of intersection lies at 54.1 kg. Wow, that's one of the importance of us using histogram to know the mode. We can use histogram to find our mode accurately without a shady of mindset. I would like us to solve a few questions so as to know how far we have gone in this topic using histogram to find our mode, especially on a group data. Thank you. Good. I'm very delighted because you have gotten the answer correctly. But if you still not get it very well, I would like you to rewind back and see how we plotted our histogram for the group data and how we use it to find our Moodle class, even our mode in terms of scores. Thank you so much. Now we have to move forward to the subtopic under it that I explained earlier on, which is called OGIF. OGIF is also called cumulative frequency curve. Cumulative frequency curve. And what is the meaning of cumulative frequency curve? Cumulative frequency curve is the sum of all frequency from the first frequency to the last frequency of that particular class. How? I will show you now. And let us consider this example. The table below shows the weight distribution of 100 people in a community. Now, let us show the weight distribution. Example 1 on this. We have the weight, which is in kg. We have the number of people, which is called the frequency. Then we have their weight for 100 people in a community. Here we have 11 to 15, 16 to 20, 16 to 20, then 21 to 25, 26 to 30, 31 to 35, and 36 to 40. Wow. What is this frequency? Between 11 to 15. How many people weigh 11 to 15? We have 8. 16 to 20, we have 12. 21 to 25, we have 15. Then 26 to 30, we have 27. 31 to 35, we have 20. Then 36 to 40, we have 18. Now, in that community that we have 100 people, 8 people weigh between 11 to 15. 12 people weigh 16 to 20 kg. 15 people weigh 21 to 25 kg. 27 people weigh 26 to 30. Then 20 people weigh 31 to 35. And 18 people weigh 36 to 40. How do we plot our graph? And how do we use this graph to find some data? Now, this is what we are going to do. Solution. We are going to draw what is called cumulative frequency table. This cumulative frequency table has its own data, has its own heading. The first thing that we have to do is class interval. That is, we are going to make it in form of class interval that the people weigh. They have class interval, they have class boundary, and we have frequency and the cumulative frequency. These are the cumulative frequency table that we will use to plot our graph. First, let's start with class interval. Here, we have the class interval. The next one, we have the class boundary. The next one, we have the frequency. And the next one, we have the cumulative frequency. Now, the class interval is 11 to 15, 16 to 20, 21 to 25, 26 to 30, and 31 to 35, and 36 to 40. Now, 11 to 15 is how many frequency? We have 8. Then 16 to 20, we have 12. Then 26 to 30, 27, 16 to 20, 21 to 25 is 15. Here we have 27. Here we have 20. And here we have 18. Now, the class boundary, I told you earlier on, how do we find class boundary? We have the upper class boundary and lower class boundary. You deduct 0.5 from the lower class boundary and you add it to the upper class boundary. Here is 10.5 to 15.5. Here is 15.5 to 20.5. Here is 20.5 to 25.5. Here is 25.5 to 30.5. Here is 30.5 to 35.5. Here is 35.5 to 40.5. That's the class boundary. Now, our cumulative frequency, we have to start from 8. 8 plus 12 will give us 20. 20 plus 15 will give us 35. 35 plus 27 will give us 62. 62 plus 20 will give us 82. 82 plus 18 will give us 100. Absolutely correct. So now we have 100 people in the community. And when you sum the frequency, is equal to 100. And these are cumulative frequency data. Now, thereafter, we are not yet through because we have gotten the data correctly now. The next thing is for us to plot our graph. I'd like you to bring out your graph once again because we've plotted the histogram. Let us bring out our graph so that we can plot our graph. Now, what is our vertical axis and what is our horizontal axis? In our vertical axis, we are going to put cumulative frequency on the vertical axis against the upper class boundary on the horizontal axis. Now, our cumulative frequency here is the least number is 8, while the highest number is 100. You can now say that 2 centimeters to represent 10 units on the y-axis and 2 centimeters to represent 5 units on the x-axis. Therefore, we start from here, 10.5. 15.5 is at which cumulative frequency? 8. We start here, 8. You locate 8 here. 8 begins from here. On the y-axis, we have 10, 20, 30, 40, 50, 50, 60, 70, 80, 90, 100. Now, Here we have 8. $10.5. The next one is 15.5. Next one is 20.5. This is 25.5. This is 30.5. This is 35.5. This is 45.5. No, 35.5, that's 40.5. Now, 8 is what we plot against this side. Then the next one is 20.5. You have what? 20.5 is at which point? Okay, 8 is here to 15. Sorry, 8 is here, which is 15.5. The next one is 20 to 20.5. You trace it here. The next one is 25.5 to 35. 35 lies here. Trace it out. We have it here. Then 30.5 to what? 62. 30.5 to 62. This is 60. 62 lies here. Then 35.5 to which one? 82. So we'll trace 82 down here to 35.5. Then 40.5 to 100. 40.5 to 100. Trace 40.5 to 100. Now, we have to join this asterisk we've gotten, and our graph look like this. So this is a cumulative frequency curve. With this curve, we can find our median, we can find our semi-interquartile range, and we can find our 80th percentile. How can we find our median? Our median is given to be n over 2, which is equal to, what is n? Our n is the total cumulative frequency curve, which is 100 over 2, which gives us 2 year 1, 2 year 50. You will trace 50 from your graph and attach it to this point. Any number that falls is the 50th percentile. Where it lies is the 50th percentile, and that 50th percentile is 28.5 kg. 28.5 kg is the 50th percentile. Check your graph very well where it lies. The second thing is 80th percentile. Just trace 80 to the graph, make it straight, 80 to the graph, and trace it down. That will give us, this is 35.5, this should be 36.5 kg. That's 80 percentile. 80 percentile, it means you trace 80 from the graph and attach to the line. That's 80th percentile. We can also determine 70th percentile, 75th percentile, 25th percentile. But in a situation whereby the question asks us that, find the semi-interquartile range. How do we find the semi-interquartile range? Semi-interquartile range, remember from our calculation, semi-interquartile range is given to be Q3 minus Q1 over 2. What is Q3? What is Q1? In our Q3, it means 3 over 4 of the total population, that is 3 over 4 of n, which is 75 percentile. This is 75 percentile, remember, in our first teaching of the statistic. Q1, it means 25th percentile. 25th percentile. So you trace 25th percentile to here and trace 75 percentile to this place. Let's trace it down, check your calculation, then you trace this 25th percentile, 25 lies here, between 30 and 20 is 25. We trace it down. So the value you got here is our 25th percentile. The value we got here is our 75th percentile. Please, I don't want us to make mistake, because once we've gotten our Q3 and our Q1, we can divide it by 2 to find our 75 percentile. And the answer to it, when you check it, is that at Q3, it is 34 kg. At Q3 is 34 kg. Check your graph. Q1, check it very well. What is your Q1? Your Q1 should be 22 kg. Therefore, Q3 minus Q1 over 2, which is 34 minus 22 over 2. What is 34 minus 22? It will give us 12. 12 over 2, 2 here 1, 2 here 6. Our semi-interquartile range is given to be 12 over 2, which is 2 here 1, 2 here 6. Semi-interquartile range from your graph is 6 kg. Please don't forget, because it lies on the upper class boundary, which is measured in kg. This one is measured in cumulative frequency. Don't make mistake. Cumulative frequency is plotted against the upper class boundary. Thank you. I would like us to solve your evaluation on this OGIF, because we've drawn the graph of this OGIF. This graph is called cumulative frequency curve, or OGIF curve. So in due time, we shall begin to solve more questions. But before then, solve this question that you're going to see on your board. By the time you solve it, I know that you'll be able to be confident to solve any question relating to statistics, type of group, or on group data. Thank you.